Chapter 4, Section 4.3, Right Triangle Trigonometry. This section is going to be mostly review from geometry and algebra 2. First of all, we're going to look at a right triangle definition for trig functions. So down in the bottom left, you see we've got a triangle. I have my theta marked where angle A is. And then I have sides little a, little b, and little c. So those are my sides. A is my opposite side because it's opposite of my theta. And b is my adjacent side because it's between the theta and the right angle. I labeled my angles as capital A, capital B, and capital C. And you'll notice that capital A is across from lowercase a, capital B is across from lowercase b, and capital C is across from lowercase c. Capital C will always be your 90-degree angle. So we define our trig functions as in terms of these sides, opposite, adjacent, and hypotenuse. So sine is opposite over hypotenuse, which would be A over C. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Something you've probably heard multiple times is SOHCAHTOA, and that's a way to remember this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Remember that if theta moves, then we change the labels of our opposite and our adjacent side. So in my picture down here, if theta were actually on angle B, then side B would be my opposite and side A would be adjacent. Example 1, evaluating trig functions. Find the value of the 6 trig functions in the figure. So the first thing we need to do is we need to know all 3 sides. I only know that B is 4 and A is 3. So I'm going to find the third side, C, by using the Pythagorean theorem. A squared plus B squared equals C squared, and we get C equals 5. Then we can find our 6 trig functions by labeling our triangle sides. Side A is going to be your opposite, side B is your adjacent, and side C is your hypotenuse. So for example, sine of theta, sine is opposite over hypotenuse, so we get 3 over 5. We also have what's called special right triangles. So this first one on the left is a 45, 45, 90 triangle, and its ratio of legs are 1 for the legs, and then the hypotenuse would be a ratio of square root 2. Likewise, we have a 30, 60, 90 triangle. Across from our 30-degree angle, we have 1. Across from the 60-degree, we have square root 3. And across from the 90, we have 2. In example 2, we're going to evaluate trig functions of 45 degrees. So first of all, we're going to look at cosecant of 45 degrees. Cosecant is hypotenuse divided by opposite. So I look at my triangle down here on the left. My hypotenuse is square root 2. And the opposite side is 1, so I have square root 2 over 1, which is just square root 2. Next, we have secant of 45, which is hypotenuse divided by adjacent. So again, we have square root 2 divided by 1, we get square root 2. And then we have cotangent of 45 degrees. Adjacent divided by opposite, 1 over 1, which is just 1. Next, we're going to find tangent of 60 degrees and tangent of 30 degrees. Tangent of 60 degrees, our reference angle is at 60 degrees, so since tangent is opposite over adjacent, we have our opposite side, which is square root 3, over our adjacent side, which is 1, which gives us square root 3. Now, when we go to find tangent of 30, we need to rethink about what our opposite and our adjacent sides are. So the 30-degree angle, opposite of it, would be 1, and the adjacent for the 30-degree angle is square root 3. So this time we have 1 over square root 3, and when we rationalize, we get a final answer of square root 3 over 3. Angles of elevation and depression. An angle formed by a horizontal line and the line of sight to an object that is above the horizontal line is called the angle of elevation. So in this example right here, we see a little person standing on a balcony. They're looking straight ahead along that horizontal dashed line. If they look up at the airplane that's an angle of elevation. The angle formed by the horizontal line and the line of the sight to the object below the horizontal line is called an angle of depression. So again, that person standing on the balcony, if they look straight ahead and then down at that car, that's the angle of depression. So make sure that when you are doing word problems that you're focusing on whether you should be opening the angle up or down from the line of sight. The irregular blue shape in the figure represents a lake. The distance across the lake A is unknown. To find this distance, a surveyor took the measurements shown in the figure. What is the distance across the lake? So if you've ever seen someone standing on the side of a road with a tripod and looking through almost like a camera type thing, that's called a surveyor. So there's someone who, in this case, might need to find the distance across this lake. So first of all, I'm going to start by labeling my sides as opposite and adjacent. And then I notice that I can use tangent, because tangent is opposite divided by adjacent. So we have tangent of 24 equals A over 750. To get A alone, I'm just going to multiply the 750 to the other side. And then I can plug that in my calculator. I get 334 yards. I rounded to the nearest whole number. The problem didn't tell me what to do, but make sure you read that in your problems on your homework and your test to know what to round to.